Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 5th grade topic, Introduction to Decimals. Now, if you're new to my channel, I can put in timecodes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any question about what you see today, or even on homework, you can always visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video will have 3 parts, so leave a like, smash subscribe, and let's get started. Now, there are many different ways to describe or define what a decimal number is. One such way is as follows. A decimal number, or what I like to call decimal, is going to be any number between 2 whole numbers. So if you have 0 and 1, any number between 0 and 1 is going to be called a decimal. Any number between 1 and 2 is going to be called a decimal. 3 and 4, any number between those two, decimal. And you can keep doing this. If you have 2 whole numbers, any number in between those 2 whole numbers is going to be considered a decimal. And when I'm talking about in between 2 whole numbers, I'm really referring to 2 consecutive whole numbers. So 0 and 1. Everything in between 0 and 1 is going to be considered a decimal. However, if you say 0 and 2, you technically do have a whole number in between. So I'm mainly focusing on 2 consecutive whole numbers. Your 0 to 1, your 1 to 2, your 3 to 4, your 10 to 11, so forth. So that's going to be one way to define what a decimal is. Any number in between 2 consecutive whole numbers. Another way you can describe or define what a decimal is going to be another form of your fractions. Now this makes sense because your fractions are going to be your parts of a whole, right? And your wholes are going to be your whole numbers. So anything between your whole numbers can be considered your parts. So if your fractions are going to be in between your whole numbers and your decimals are going to be in between your whole numbers, that means your decimals and your fractions should be the same thing. So your fractions are going to have another way of writing them, and that's going to be your decimal form. So anything between your 2 consecutive numbers will have a fraction form and a decimal form. And another way of describing or defining what a decimal number is, or a decimal is going to be any number that has a decimal point. This last one, we'll talk about this a little bit more in our 3rd part of this video, so make sure you stay tuned. However, before we move on to our 2nd part of the video, there's one thing I really need you to understand. Your whole numbers count the wholes. Your decimals are going to be used to count the parts. Just like your fractions are going to be a part of the whole, your decimals are also going to be part of the whole. We're going to be using decimals to count the parts, and your whole numbers are going to be used to count the wholes. So using decimals when you're counting is mainly going to be needed when you have additional parts outside of your wholes. Similar to your whole number place values, your decimal numbers will also have decimal place values. And we have some good news to work with. For your whole number place values, there was a certain pattern that existed that we can make use of in order to find our decimal place values. So let's quickly go over what that pattern was for our whole number place values. Remember, whenever we're talking about whole number place values, the very first place that we're looking at is going to be our ones place. And whenever we needed another place value, the first pattern we run into is we had to keep adding to the left. We're going to be adding this way whenever we want more place values. So our next place value is going to be put to the left of our previous one. And this one was called our tens. And then we added another one. And this one is called our hundreds. And then we added another one. This one was our thousands. And then we added another one. And this was 10,000s. And then we added another one. And this was 100,000s. Now, there's another pattern that we can take advantage of here as well. Whenever we added more place values, we noticed that all we did was multiply our previous place value by 10. So to get from here to here, we did times 10. To get from here to here, we did times 10. And we kept doing this for every additional place value. Each place value, when you go to the left as you're increasing your place value, is going to be times 10 the previous one. And it makes sense if you look at it. 110 is going to be 10 times 1. 100 is going to be 10 times 10. 1,000 is going to be 10 times 100. And you keep doing this. So the two-part pattern that we see here is that every time you need a new place value, you're going to be adding to the left. And you're going to be multiplying by 10 in order to get to that next place value. This same pattern can be used to find our decimal place values. Now I said that same pattern can be used, but actually it's going to be the reverse of that pattern that we just talked about. Now remember, you start at ones. You're always going to be starting at ones. However, instead of doing times 10 to go to your left to find tens, like you did for your whole numbers, for your decimal, you're going to be dividing by 10, adding to your right to find something we call tenths. So you see, we're doing the opposite of what we did for our whole numbers. And we can keep going. Instead of doing times 10 to find your hundreds, we can divide this by 10 to find your hundredths. Now I'm writing this not so neat, so let me make sure I'm stressing this and what you're actually seeing here. This first place value to the left of your ones is going to be tens. This first place value to the right of your ones is going to be tenths. Notice this has a TH. Similarly, this second place value to the left of your ones is hundred. The second place value to the right of your ones is going to be hundreds. Notice TH. So you see another pattern that we can make use of. The naming convention for our decimal place values are going to be very, very similar to the naming convention of our whole number place values. The only addition is going to be TH. And this is going to be true for all of the place values. So you can go to 1,000, 10,000, 100,000, million, and you're going to be doing the same type of thing here. You can go to thousandths, 10,000ths, 100,000ths, millionths. So as long as you're adding the THs and you're adding more place values to the right, this can keep going on forever, just like you can go on forever to the left. So if you ever forget your pattern for your decimal place values, just know you're doing the opposite of the pattern for your whole number place values. Now at this point, you may be a little confused because for your whole numbers, you always started at the right. Your rightmost number is your ones place. But now I'm telling you, you're going to be adding more and more and more place values to the right. So how do you know which one's your ones place? That's when we're going to need a divider or a separator to tell us what our whole number place values are from our decimal place values. And we have that divider and we call it a decimal point. Your decimal point is always going to be right next to your ones place. So your ones, let's say you have a ones place here, and it's, let's say, 5. Your decimal always goes right here whenever you need a separation between your whole number place value and your decimal place values. Right next to your ones is where you place your decimal point. This dot here, this period, is what we call a decimal point. Now we can easily tell what our whole number place values are from our decimal place values. Anything to the left of your decimal is going to be a whole number place value. So you can keep doing the same thing. Remember, it's going to be times 10 to figure out what your next place value is going to be to the left. This is your tens place. This is your hundreds place. and so forth and so forth. Anything to the left is a whole number place value. However, anything to the right is going to be your decimal place value. So we're going to be dividing by 10 and adding to the right to find your tenths. Dividing by 10, right? And adding to the right to find your hundreds. That decimal point is what's going to be used to separate the two. Now, not all numbers will have a decimal point on it. Remember, your counting numbers, 1, 2, 3, 4, 5, etc., they don't have any decimal points here. And that's perfectly fine. These are just whole numbers. You don't need a decimal point if you don't need to separate your whole number place values from your decimal place values. So if you don't have any decimal place values, there's no need to have a decimal point. However, you can still put it there and not have anything afterwards. There's nothing wrong with that. So technically your counting numbers can be 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, and etc. It doesn't hurt to have it there, but remember, this is just used to separate your whole number place values from your decimal place values. If you don't have any decimal place values, there's really no need to put the separator there. However, if your number does have decimal place values, you will definitely need a decimal point. So let's say you had a number like this. Remember, this number is what we call a decimal number because it has a decimal point in it. And we notice that we have decimal place values, so we need that decimal point in order to be able to understand what kind of number we have. And when you do have a decimal point in your number, we consider the number of numbers after your decimal point to be the number of decimal places your entire number has. So when you look at this, we see we have a number with 2 decimal places because there are 2 numbers after your decimal point. So this number has 2 decimal places in it. If you have a number like this, we say that this number has 1 decimal place in it because it only has 1 number after the decimal, to the right of the decimal. When we say after the decimal, we mean to the right of the decimal. It doesn't matter how big you are to the left of the decimal. However many numbers you have after or to the right of your decimal is how many decimal places your number has. So this one has 1 decimal place. Let's say you had a number like this. This number has 5 decimal places because it has 5 numbers after your decimal. So once again, it doesn't matter how many numbers before your decimal or to the left of your decimal. We're only counting how many numbers you have to the right. This is going to tell you how many decimal places you have in this number. But let's say you have a number like this. How many decimal places do we have for this number? See, we have a 0 here and we have a bunch of zeros here. Do we just say we have 3 decimal places? No. Even though you have zeros right here, you still have 5 numbers after your decimal place. So this number, as is written here, has 5 decimal places. So I hope you have followed today's examples, and I hope you now know a little bit more about your decimals. However, if you have any questions about what we see today, or even on homework, remember, you can always visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you next week. I'm Courtney, and this has been another session of Tutor Me Sempai.